Hello aspirants, welcome back to our channel Foodtech Online. Hope you all are doing good. Question. Adult male Western rats were fed with a protein which based diet. Total 150 gram of protein was ingested. So, uh, what is the protein which has been consumed or ingested? That is 150. 150 gram. If the average weight increased from 110 to 350 grams, so initial weight is 110 gram, final weight is 350 gram. We have to calculate the protein efficiency ratio of the given. It would be how much? We have to calculate it up to 2 decimal points. So protein efficiency ratio formula is weight gain in grams divided by protein intake, also in grams. So over here, what is the weight gain of the rats? It is calculated by final minus initial divided by what is the protein intake of it. That is 150 gram. So 40 divided by 150 gram, that is around 1.60. So this is my answer. Moisture content of a food on weight basis is 50.76%. Its moisture content on dry basis is how much? So we have to convert moisture content from wet basis to dry basis. So the formula is moisture content on dry basis is moisture content wet basis divided by 100 minus moisture content wet basis into 100. So what is the moisture content on wet basis? That is 50.76 divided by 100 minus 50.76 into 100, or it is minus 49.24 into 100. Approx will get 103.08%. So this is the moisture content on dry basis. Answer. 2.54 into 10 to the power minus 3 centimeter thick low density polyethylene film with air on one side and inert gas on the other side is 3.5 into 10 to the power minus 6. Oxygen partial pressure difference across the film is 0.21. The permeability coefficient of the film to oxygen is how much? Okay, so film thickness is given. We'll denote it by x, that is 2.54 into 10 to the power minus 3 centimeter. Now oxygen transmission rate, it is 3.54 into 10 to the power minus 6 ml per centimeter to the power minus 2 per second. And partial pressure difference, that is del P, it is given as 0.21 atm. And we need to find over here the permeability coefficient. So we'll denote it by Q over here. Okay, over here Q by 8 will be, since area centimeter has been given, so our permeability coefficient, that is P, is equal to Q into X by A into del P. Just put the values over here. Q by A, they have given the value, that is 3.54 into 10 to the power minus 6. X is 2.54 into 10 to the power minus 3 divided by the difference, that is 0.21. Okay. Acha, over here it has been given in atmosphere. We have to convert it into centimeter. So it will be, we know that 1 atm is equal to 76 centimeter He. So over here it will be 0.21 into 1 atm. So it will be 76. So if we'll calculate this, we'll get 15.96 centimeter mercury. So over here, after calculating, we'll get 55.7 into 10 to the power minus 11. Which is my answer. So my answer over here will be 55.7 ml. Ambient air at 30 degrees Celsius dry bulb temperature. So this is my initial T1, and 80% relative humidity, that is RH, to a dry bulb temperature, that is T2, in a heat exchanger by indirect heating. Okay, it's a bit tricky question. The amount of moisture gained during the process would be how much? Since we read that in indirect sensible heating, what happens? The moisture content, it will remain constant. So in indirect sensible heating, moisture content remains same. Sorry, constant. That means the humidity ratio, or we will say that specific humidity, it will not change. So omega 1 will be equal to omega 2. So moisture gain or loss will be equal. That means our answer would be 0 over here. Microbial sample was taken at 10 am, which contained 1 into 10 to the power 10 CFU per ml. And the count, it reached to 1 into 10 to the power 10 CFU per ml at 10 pm. So the growth rate of the microorganism would be how much? Okay, so at 10 am, count is 1 into 10 to the power 5 colony forming unit per ml. At 8 pm on the same day, the count is 1 into 10 to the power 10 colony forming unit per ml. So total time taken, we can calculate it. 10 am to 8 pm, that is 10 hours. We have to calculate the growth rate over here. that is K. So we know the formula that K is equal to log base 10 of, if we'll say this as NT, that is final, and this as N naught initial, that is NT minus log base 10 of N naught divided by 0.301 into the time taken, that is 10. So we'll just put the values 10, 10 minus 5 by 0.301 into 10 to 10, that is 1.6 hour. So the growth rate of the microorganism will be 1.66 hour. An enzyme catalyst reaction substrate to product, the kinetic parameters, so given S is 40 micro, then V naught is 9.6 micromolars per second, V max is 12, and we have to calculate the Km value. So this question is about Michaelis-Menten equation. What was the equation? That is V naught is V max into S by Km plus S. We'll just put the values. 9.6 is equal to 12 plus this we have to calculate plus 40. So it will be 9.6 Km plus 40 is equals to 12 into 40, or 9.6 Km plus 384, 12 fours are 48, or we'll get 9.6 Km is equal to 480 minus 384, or Km will be 10. So over here my correct option answer will be 10. From a metal plate is 1000 watt per meter square. The surface temperature of the plate is 120 degrees Celsius, ambient temperature 20 degree, convective heat transfer coefficient we have to calculate using the Newton's law of cooling. So in formula we know that Q is equals to H A delta T. Now what is Q? Q is rate of heat transfer. H is my convective heat transfer coefficient. A is my area, and delta T is the temperature difference. That is over here it is Ts minus T infinity. that means surface temperature, and this is my ambient temperature. Since over here rate per unit area is given, that means Q by A is given to us, which is how much? 1000 watt per meter square. T as it is surface temperature is given 120 degrees Celsius. Ambient temperature is 20 degrees Celsius. We'll just put the value and calculate H. So H will be 1000 divided by 120 minus 20, or it will be 1000 by 100, which is 10 watt per meter square Celsius. This is my answer. Fat particle inside a centrifuge which is running at 6000 rpm and 20 degrees Celsius is 0.2 mm per second. Velocity of 1.5 micrometer diameter fat particle inside the centrifuge tube which is running at 7500 rpm at same temperature will be how much? We have to calculate. Now what are the things it is given? First one, velocity, that is 0.25 mm per second. V2 we have to calculate. Then diameter, that is 2.2 micrometer. D2 1.5 micrometer. N1 that is 6000 rpm. And N2 that is 7500 rpm. Now we know the formula that in the centrifuge the principle of sedimentary velocity, that is V is directly proportional to diameter square and its rpm. So we can just write the formula V1 by V2 is equal to D1 by D2 square into N1 by N2 square. We'll just put the value over here and calculate V2. So V2 will be V1 into D2 N2 square by D1 N1 square, which is equal to 0.25 into 1.5 square into 7500 rpm divided by 2.2 square into 6000 rpm square. Calculating this, we'll get the value of V2, which will be around 0.18 mm per second. Now we have to round it off to 2 decimal places. So we can write like V2 is equals to approx 0.2 mm per second. So this will be my answer. It increases from 1 into 10 to the power 4 cells per ml to 1 into 10 to the power 6 cells per ml in 120 minutes. The generation time for this train is how much we have to calculate. So we know the formula that Nt is equal to N0 into 2 to the power n, or using log we can say that n is equal to log Nt minus log n naught by log 2. We know the value of log 2, that is 0.301. So we'll put that value. So n is equal to log nt. It is given that 10 to the power 6, 1 into 10 to the power 6 log minus log 1 into 10 to the power 4 by log 2 is 0.301. We'll just calculate it. So 6 log 10 minus 4 log 10 by 0.301, or 6 minus 4, that is 2. Log 10 is 1. So 2 by 0.301, which is equals to 6.641. Now this is the value of n we got. Now generation time, it is equals to time by n. So time it has been given, that is 120 minutes, and we have to find the answer in minutes. So no need to convert it, that is 120 by n, that is 6.641. So G is equal to 18.06. So our answer will be 18. Double pipe heat exchanger at 20 degrees Celsius and it leaves at 72 degrees Celsius. Inlet and outlet temperature of the hot water which is used as a heating medium in the exchanger are 81 degrees Celsius and 74 degrees Celsius respectively. The specific heat of the orange juice is 3.74 kJ per kg Kelvin and the overall heat transfer coefficient is 492 watt per meter square Kelvin. The heat transfer surface area, this we have to calculate. So first we'll write what are all the things given. First of all, mass flow rate of the orange juice, that is MC, it is 0.8 kg per second. Inlet temperature of the orange juice, that is TC in 20 degrees Celsius. Outlet temperature 72 degrees Celsius. Outlet temperature of the inlet temperature of the hot water 81 degrees Celsius, and outlet temperature of the water is 74 degrees Celsius. This is inlet, this is outlet. Specific heat of the orange juice 3.74 kilojoule per kg Kelvin. And overall heat transfer coefficient is given as 492 watt per meter square Kelvin. So first we'll calculate the rate of heat transfer for the orange juice, that is Q equals to m Cp delta T. M is given as 0.8, Cp is 3.74 and delta T, that is 72 minus 50, it is 52. So it is 150.584 kilojoule per second, or we'll write it as 150.584 joule per second. Now we'll calculate log mean temperature difference, that is delta T Lm. So it is the TCI minus the THO. So it is 20 minus 74, since it's a counter current, minus TCO, that is 72 degree, minus THO, that is 81 degrees Celsius, divided by log 20 minus 74 by 72 minus 18. So we'll calculate this. We'll get minus of 54 minus of minus 9 by log minus 54 by minus 9, or minus 45 by 1.653, which is equal to 27.22 approx. Now we'll just put this all in area formula, that is A is equals to Q by U into A delta T ln. Q we have calculated 150,584, U it is 492, and delta TLM we calculated it is 27.22, which is equals to 11.2 meter square. Hence our answer is 11.2 meter square. Here, the percentage relative humidity of the air leaving the dryer is 60% at 70 degrees Celsius, and this is the total pressure, that is 101.35 kilopascal. And if the saturated vapor pressure at 70 degrees Celsius is 31.2 kilopascal, we have to calculate the humidity of the air which is leaving out the dry air. So what are the things given? Relative humidity, that is 60%, temperature 70 degrees Celsius, total pressure 101.35 kilopascal, and saturated vapor pressure of water at 70 degrees Celsius, that is Psat, is 31.2 kilopascal, and molecular weights of water and air is given. Molecular weight of water, that is 18.0 gram per mole, and molecular weight of air is 28.97 gram per mole. And we have to calculate the humidity of the exit air. First we'll calculate the partial pressure of the water vapor, that is PV. We'll calculate. So we know the formula that RH is equal to PV by Psat into 100, or PV equals to RH into Psat by 100, or PV equals to 0.6 into Psat is 31.2, that is equal to 18.72. Now H is equal to molecular weight of water by molecular weight of air into PV by P minus PV. We'll just put the values. 18, H equals to 18.02 into 18.72 divided by 28.97 into 101.32 minus 18.72. Calculating it, we'll get 337.33 divided by 2394.6, which is equals to 0.141 or kg water per kg dry air. This is my answer. So my answer is 0.141. 100 kg paddy is dried from 18% wet basis to 13% wet basis moisture content. Now the amount of water which is removed in kg from the paddy is how much? So we'll write first the initial moisture content of the paddy is how much? That is 100 kg. And the initial moisture content is 18% wet basis. Correct. Now final moisture content is also given, that is 13% wet basis. We have to calculate the amount of water which is removed. So for that we need first the final weight of the paddy, that is WF, we have to calculate. So we know the formula that WF is equal to WI into 100 minus initial moisture content by 100 minus final moisture content. We'll just put the values over here. Initial is 100 minus moisture is 18 divided by 100 minus 30. So we'll get a value that is 94.25 kg. So this is my final weight of the paddy, WF. Now we have to calculate the water, which is amount of water which is removed. We can just say that amount of water which is removed, that is from initial weight of the paddy minus the final weight of the paddy, will get the amount of moisture which is removed. That will be 100 minus 94.25, which is equal to 5.75 kg. So this is the amount of water which is removed from the paddy, 5.75. Canning industry, the total processing time, that is F naught, is calculated as 3 minutes, and each can contains 20 spores having a decimal reduction of 1.6 minute, and the probability of spoilage will be how much in 100 cans. We have to calculate. So F naught is given to us, that is 3 minutes. And each can has 20 spores. And decimal reduction time, that is D value, it is given as 1.6 minute. And we have to calculate the probability of spoilage for 100 cans. So probability of spoilage, what's the formula? 1 by R equal to N naught by 10 F by D. Just put the values over here. 1 by R we have to calculate, which is the probability of spoilage. N naught, that is each can has 20 spores. So 20 divided by 10, F naught value is given to us 3, D value is 1.6. So we'll get the value as 0.266. Now we need it for 100 cans. For 100 cans. This is for 1 can, the probability of spoilage. So for 100 cans, it will be 100 into 0.266. That is equal to 26.6, or approximately we can say 27 spores. So for 100 cans, probability of spoilage will be 27. Diameter tube at 60 degrees Celsius, leaves at 57 degrees Celsius, heat loss is 381, and specific heat with density and viscosity is given to us. We have to find out the Reynolds number for the flow will be how much. So first of all, let us write what are the things given to us. So Q loss is given, that is 381.15. Temperature difference will be how much? It is 60 degrees Celsius minus 57 degrees Celsius, that is 3 degrees Celsius is my temperature difference. Specific heat capacity, CP, is given to us as 3.85 kilojoule per kg Kelvin, or we can convert it to joule per kg Kelvin, that is 3850 joule per kg Kelvin. Now, density is given to us as 1020 kg per meter cube. So we'll just calculate the mass flow rate over here. It is m dot. We know the formula of mass flow rate, that is Q by delta T Cp. We'll put the values. Q is 381.15 by delta T is 3 into Cp 3850. So we'll get the value as 0.0330 kg per second. Okay. I'll change the pen over here. Now we know the density, we can calculate the volumetric flow rate. That is QV, our volumetric flow rate. So it's mass flow rate by density. So mass flow rate is 0.0330 by density is 1020. So it is approximately 3.235 into 10 to the power minus 5 meter cube per second. Now the pipe diameter, that is D, is given to us as, so this is our D, diameter of the pipe. It is 2 centimeter. So we'll convert it into meters, that is 0.02 meter. And cross-sectional area, we know the formula, that is, since it's a circle, so it will be pi r square. Diameter is given to us, so it will be pi d square by 4. We'll put the value. Pi value is given to us 3.14 into d is 0.02 whole square by 4, and it is equal to 0.0000314. Okay, now we need to calculate the mean velocity. I'll change the color. So we need to calculate the mean velocity. Mean velocity will easy to calculate by volumetric flow by the area. So we'll get the mean velocity of the flow. So QV is 3.235 into 10 to the power minus 5 by area is 0.000314. So it is approximately 0.1030. meter per second. Now we can find out the dynamic velocity since we got the mean velocity. So dynamic velocity mu will be equal to 1.20. It's given to us the dynamic viscosity of the fluid. So it can be written as 1.20 into 10 to the power minus 3 Pascal since it's centripoise. So Reynolds number will write Reynolds number what's the formula? Rho into V into D by mu. Just put the value over here. I'm not having space. So density is 1020. So we have the density 1020. V we have calculated, that is 0.1030. D we know 0.20, 0.02, and mu is 1.20 into 10 to the power minus 3. So we'll get the value of approximately 1751.6, or approximately it is 1752. So my answer will be 1752. Here, inside the storage chamber is 37 degrees Celsius, 50% respectively. Saturation pressure is at 37 is 6.28 kilopascal, and barometric pressure is 101.32 kilopascal. Humidity ratio I have to calculate, and the molecular weight of water vapor and dry air are given to us. So for calculating the humidity ratio, that is W, we know the formula, that is mW by MA into PV by P minus PV. So first we have to calculate PV over here, and to calculate PV we know it is relative humidity into PSAT. Relative humidity is 50%, that is 0.5, and PSAT is given to us at 37 degrees Celsius, that is 6.28. So we'll just put the value over here, 0.5 into 6.28. So it is equal to 3.14 kilopascal. Just put the values over here now. MW value is given to us as 18.02. MA, the value is given to us as 28.97. PV we just calculated, that is 3.14. P, it is given to us as 101.32. Minus 3.14. So our value will be approximately 0.0198 kg of water per kg of dry air. Or approximately we can say 0.02. So our answer will be 0.02. Calculate the efficiency in percentage and then round it off to 1 decimal place of an oil expeller which yields 37 kg of oil containing 5% solid impurities from 100 kg of mustard oils. So total mustard oil we are having is 100 kg. In that we are having 5% impurities. So pure oil we are having as 100 minus 5%, that is 95%, or in kg we can say pure oil. So it has been given yield is 37 kg. So it is 37 into 0.95. So we'll get a value that is 35.15 kg of pure oil we are having. Now we have to calculate the theoretical oil content. Theoretical oil content. So we are having oil content of mustard seed as 38%. So in kg if we want to calculate, that is 100 into 0.38. So we'll get 38 kg. Now we have to calculate the efficiency. So it is actual oil which is obtained by the theoretical oil. Oil content. So actually we are having 35.15 kg. Theoretically we are having 38. Just divide it. We'll get approximately 92.5%. So the efficiency of the oil expeller is 92.5%. This is my answer. Juice is packed aseptically and stored under ambient condition. The degradation of vitamin C in the orange juice during storage, and it follows first order kinetic. The degradation rate is given and we have to calculate the half-life of vitamin C in days. So first order reaction, so rate constant K over here it is given us as 5.2 into 10 to the power minus 3 per day. Now we have to substitute it to T half. So it's just 0.693 by K, or put the value of K over here, 0.693 divided by 5.2 into 10 to the power minus 3. So it is approximately 133 days. So over here my correct answer will be 133. Basis, after rehydration it is gaining 60 kg. Now if the fresh cauliflower it contains 87% moisture content wet basis, we have to calculate the coefficient of rehydration. So first of all, what all things are given to us? Weight of dried cauliflower. So weight of dried cauliflower, it is 10 kg. Moisture content of dried cauliflower, that is 5%. Rehydration, it is gaining 60 kg. And moisture content of the fresh cauliflower is 87%. Now, since we know the moisture content of the dried cauliflower, we can say if it's 5%, so solid percent will be how much? It will be 100 minus 5 will be my solid percent. It is 95%. Now dry matter, from this we can calculate since we know the weight of the dried cauliflower. So it is 10 into 0.95, which is 9.5 kg of dry matter. Now let us assume that the fresh cauliflower as W. So let W the fresh cauliflower weight. Now since moisture content of fresh cauliflower is 18%, so solid matter will be 13%. Now we have to calculate the fresh cauliflower weight. Similarly, we can say that 13% means 0.13 into the weight which we are assuming is equal to 9.5, the dried one, solid matter. So W will get as 73.08 kg. So from here we can now calculate the coefficient of rehydration. So this 73.08 kg is the original fresh cauliflower weight. So over here, coefficient of rehydration that is the weight which is after rehydration. It is 60 kg after rehydration, and here we calculated the equivalent fresh weight, that is 73.08 kg. So it is approximately equal to 0.821. Now we have to round it off to 2 decimal place, so it will be 0.82. So this is our correct answer. Glucose isomerase, it converts 15 micromoles of substrate glucose into product fructose under standard assay conditions. So we have to calculate the enzyme activity of glucose isomerase in international units. We know that 1 IU, that is international unit, is equal to the amount of enzyme that converts 1 micromole of substrate per minute under the standard condition. So over here it is given to us that if activity is 15, that is 15 micromole per minute per liter. So for 1 ml of enzyme sample, this is. So enzyme activity is, this is for 1 ml of enzyme sample, and we know that 1 IU is which it converts 1 micromole per minute per liter under standard conditions. So we can say hence that activity will be activity for 15 micromole per minute per liter will be 15 IU per ml. For 1, if it is 1, then for 15 it will be 15. So enzyme activity will be 15 IU. D10 for salmonella in egg yolk is 0.75 kilogram. We have to calculate the radiation dose in kilogram, where the salmonella count in egg yolk is given to us as 18 log cycles. So first of all, D10, it is 0.75 kilogram, and the reduction is required reduction 8 log cycle. So So dose we can calculate, dosage. Formula is D10 into the number of log cycle, that is 8. So it is 0.75 into 8 or 6 kilogram. So this is my answer. So the radiation dose which is required is 6 kilogram. Of a textured protein product at 8% moisture content is 3200, and if water activity above moisture content is 0.3 at 30 degrees Celsius, we have to calculate it at 45 degrees Celsius. So the moisture binding energy, that is delta E, is given to us as 3200 calorie per mole, and AW1 at 30 degrees Celsius is 0.30. AW2 we have to calculate. T1, that is 30 degrees Celsius, it is 303 Kelvin. T2 is at 45 degrees Celsius. At Kelvin it will be 318 Kelvin, and R is given to us. We'll just put the formula, that is ln AW2 by AW1 is equal to delta E by R 1 by T1 minus 1 by T2. So we'll just put the values over here now. So ln AW2 we have to calculate. AW1 is 0.3 equal to 3200 by 1.987 into 1 by 303 minus 1 by 318. So we'll get the value over here of AW2 as approximately 0.3849, or approx we have to just round it off to 2 decimal place. So it will be AW2 is 0.38. This is my answer. Content, that is 90%, to final moisture content 35% wet basis. So we are having 10 kg tomato, 90% moisture content, which has been concentrated. So it is a evaporator over here. Now it has been concentrated to 35% moisture content, and say W amount of water has been removed, and we are getting pkg of product. So first of all, we'll do total mass balance. So 10 kg product P plus W, or we can say Rp is equal to 10 minus W. So let this be my first equation. Now moisture balance. So moisture balance. So we are having 10 kg having 90%. So it is 0.9 equal to 35% final. So it will be 0.35 into P plus W. Now we'll just put the value of P over here. So it is 9 is equal to 0.35 into 10 minus W plus W, or 9 is equal to 0.35 into 10 minus 0.35 W plus W. So when we'll calculate the value of W, we'll get the value as 0. It is 8.461. This is the amount of water which has been removed. Now we have to calculate the amount of product. That means P. For calculating P, we know we'll just put the value of W over here and we'll get. So from total mass balance, that is 10 is equal to P plus W. So P we don't know, plus 8.461 is equal to 10, or we can say P is equal to 1.538 kg. So this is my answer. And the bulk density of the wheat grains are given to us, we have to calculate the porosity of the grain. So first, what all things are given to us? True density, that is 1280 kg per meter cube, and the bulk density 740 kg per meter cube. Now we know the formula of porosity, that is 1 minus the bulk density by its true density. We'll just put the formula values over in this formula. So my answer will be around 0.42. So we can say that 42% is the porosity of the grain over here. So this is my answer. Z value at 11 degrees Celsius is 2.4 minutes for 99.4 times 9 means it's a 6D process. Just calculate the number of nines. Inactivation. For 12D inactivation of the said microorganism at 143 degrees Celsius. So what all things are given to us? First, F121 is 2.4 minute. Next, Z. So Z is 11 degrees Celsius. It's a 6D process and the target is 12D at 143 degrees Celsius. First, we'll calculate the D value. So D at 121 is 2.46D. So D at 121 will be 2.4 by 6. It is 0.4 minute. We'll just now adjust the D value for temperature change. So we know the initial temperature and the final temperature. So we can calculate. So final is 143 degrees Celsius. Initial is 121 degrees Celsius. We'll get 22 degrees Celsius. Just divide this 22 by Z. We'll get Z is 11 degree. It's 2. So with each rise of 1 Z, it reduces D by a factor of 10. That means D at 143 is equal to D at 121 by 10 raised to 2. D at 121 we calculated it as 0.4 by 100. So it is 0.004 minute. Now we'll just calculate the F value. So F value at 143 is 12D process, means 12 into D 143. So 12 into 0.004 or 0.048 minute. So this will be my correct answer. Grinding operation, 80% of the feed material it passes through the sieve opening of 4.75 mm, 80% of ground it passes through 0.5 mm opening, and the power required to grind 2 tons per hour is 3.8. So we have to calculate the work index. We'll simply use Bond's law of grinding. So what is the formula of Bond's law of grinding? E is equal to 10 into work index into 1 by root over product at 80 by root over feed at 80. Now energy over here, it's 3.8 kilowatt per 2 tons. That means 3.8 per 2 tons is 10 into work index we have to calculate by 1 by root over P80 is 4.75 mm. That means 4750 micrometer, and feed is ground is 500 micrometer. So we'll just calculate and we'll get Wi as 6.29 kilowatt hour per ton. So this will be our correct answer. Hope you liked this session. Till then, thank you and enjoy learning.